So in this video, we'll take a look at second order ordinary differential equations, which are linear, homogeneous, with constant coefficients. So these equations can be written in this form. Okay, so the method for solving these equations, so the method is like this, very simple. So first, write what is called the characteristic equation. Characteristic or auxiliary. Sometimes you will see it called characteristic, sometimes auxiliary equation. Which is the quadratic equation AR squared plus BR plus C equal to 0. So write the characteristic auxiliary equation and then solve this quadratic equation. Then there are of course three different cases. First, if, so let me call this equation perhaps number 1, this one number 2. If 2 has two distinct real solutions, so the characteristic equation has two different real solutions, R1 and R2, then the general solution of one is y equal C1 E R1t plus C2 E R2t, like this. Number 2, if the characteristic equation 2 has a double root or solution, just one double root R, then the general solution of the differential equation 1 is y equal C1 ERT plus constant C2 multiplied by T ERT, like this. And finally, third and final case, if the characteristic equation 2 has two complex solutions, two complex roots or solutions, so two complex roots which are conjugate, so they will be of the form alpha plus or minus I times beta, then the general solution of our ODE 1 is y equal E alpha t C1 cosine beta t plus C2 sine beta t, like this. So these are the three cases. Here's the first example. I want to solve this differential equation y double dash plus 4y dash plus 3y equal to 0. So the characteristic equation is r squared plus 4r plus 3 equal to 0, which has two roots. R1 equal to -1 and R2 equal to -3. It's fairly easy to check that these two numbers are the solution of this characteristic equation. That means, so, the general solution of this equation number 1 is y equal to C1 e minus t plus C2 e minus 3t. That is the general solution of the equation. Second example, solve y double dash minus 4y dash plus 4y equal to 0. Okay, so first, the characteristic equation. So let's write the characteristic equation, which will be r squared minus 4r plus 4 equal to 0, which is the same as r minus 2 squared is equal to 0, which means that we have a double root r equal to 2. Because the characteristic equation has a double root, then the solution of the ordinary differential equation number 1 here of 1 is y equal to C1 e to t plus C2 t e to t. So that will be the general solution of equation 1 in this case. Third and final example, I want to solve this ordinary differential equation to y double dash plus y equal to 0. Well, again, first step is the characteristic equation. Which in this case is simply 2r squared plus 1 equal to 0, which means that r squared is minus half, which means that r is either plus or minus the square root of half times I, which I can write as square root of 2 over 2 plus or minus times I. So here, our characteristic equation has two complex solutions. Of the form alpha plus beta I, where alpha then is just 0. The real part of this complex root is 0. And the beta is square root of 2 over 2. Therefore, the general solution so this result here is of course important. The general solution of our equation, let's call it number 1, is, remember, it's of the form E alpha t C1 cosine beta t plus C2 sine beta t. So in this case, that means y is alpha is 0, so this is actually going to be 1, so no need to write it. So we get C1 cosine square root of 2 over 2t plus C2 sine square root of 2 over 2t, where C1 and C2 are arbitrary constants, like this.